Okay, so here we have two cars starting moving from the same point. One is going south at the speed of 60 miles per hour, while the other one is going west at the speed of 25 miles per hour. We would like to know at what rate is the distance between the cars increasing 2 hours later. So here, picture time. Let's say right here, this is the same point that they were starting with, and then have a car right here, and it's going to go south, right? And then I have another car, it's going to go from here, going west. And it says 2 hours later, so I will show you guys another picture. After 2 hours, well, this car will be just much further down. So let's say this was the original point that they had, and this will be going down, right? And so this is where the car is. And then the car right here is going west, so it will be like this. Okay? And notice that right here I draw this to be longer because I see that the car that's going south is going at the speed of 60 miles per hour, which is faster than the one that's going west, right? The west car is only 25 miles per hour, so I know this distance has to be longer than that one. So here's the picture for it. And then we are talking about the distance between the cars. At first, the cars were at the same point, right? But then after 2 hours, this is how we measure the distance between the cars. From here directly to the car, right? From this one to the other. So as you can see, here we have a right triangle. And you see that this distance changing, right? The horizontal distance changes. The vertical distance also changes. And then this red distance also changes. Everything changes. Therefore, we are going to label everything right here with variables. So let's do it. The horizontal distance, I will just label that with x. And then this vertical distance, I will just label that with y. And then this, I will just label with z. Okay? And as you can see from this picture, we are talking about a right triangle. And the sides of a right triangle can be related with the Pythagoras theorem. So let me write it down. We know that x squared plus y squared has to be z squared. So this is the equation with all the sides. And then everything changes. I would like to just look at this equation now and then take the derivative with respect to time. So let's see. Derivative of x squared with respect to time, we will get 2x, and then because x is a function of time, we multiply by dx dt because of the chain rule. Likewise, we do the same thing right here. So we plus 2y dy dt, because y changes with respect to time as well. The last part we have 2z dz dt. The z distance right here also changes. Alright, so now we have an equation with the derivative, namely the rate equation. As long as we figure out what's x, dx dt, y, dy dt, and z, we can solve for dc dt. Because the question right here, it says at what rate is the distance between the cars increasing. We're trying to find out what dc dt is. Because you see the rate means the derivative. The distance between the cars is this one. So that's why dc dt, we don't know. We want to find out. Okay, so let's see if we can figure out x. Well, right here, x is this car that's going to the west, right? And x is the quantity, this is the actual distance. Well, how long is this? We know the car that's going west. Let's looking at this. The car that's going west is going at the speed of 25 miles per hour. In fact, I know dx dt will have to be 25. And let's ignore the unit for now. We'll just write down 25. That's the speed of this car right going toward the west. And the actual distance, x will be, well, 2 hours times the speed, which is the 25, right? 25 miles per hour. If you drive 2 hours, you are going to drive 50 miles. Okay. Likewise for the y, let's see. The car that's going south is going at the speed of 60 miles per hour. So we know that dy dt has to be 60. And then similar idea, y will be after 2 hours, I have to just do 2 times 60 because that's the time times the speed. We have 120 then. Okay. Alright, so we know the x value, which is 50, and then we also know the y value, which is 120. Do we know the z value? Yes, we do.
Because once again, x squared plus y squared has to be z squared. X is 50, so 50 squared plus y squared, which is 120 squared, we will get z squared, right? And then, you can just do the algebra. Let me just show you real quick. This is going to be 50 squared, which is 2500 plus 14400, and that would be z squared. And you can add this up, so that means z squared would be this plus that, which is 16900. And of course, you do the usual business, square root both sides, and just take a positive square root. So we are talking about z is equal to 130.
We have all the ingredients now. Plugging into this, we will be able to solve for dc dt. So 2, x value is 50. And how about the dx dt? Do we know about that? Yes, is this, which is 25. Sorry, right here, 25. That's the speed for the car. Plus 2 times y. So let me open the parentheses. The y value is 120. So let me put on 120 right here. And then dy dt is 60. And all that will be equal to 2 times c value. The c value is 130. And then dc dt, we don't know, so we keep it as how it is for now, dc dt. And to solve for dc dt, let's divide both sides by 2 parentheses 130, so that this and that will cancel. And then I will need to divide everything on left hand side by 2 parentheses 130. And then all we need to do is say dz dt is equal to this number. So use a calculator, punch everything onto the calculator. We will get this is equal to positive 65. And we know the sign is correct because the distance between the cars is getting longer and longer. So this is the correct sign, positive 65. And then this is the speed, so we know we're talking about miles per hour. So just indicate that miles per hour mph. And then we will be done. That's it.